Okay. Hello, everyone. May I have your attention, please?
Wait a second.
Yes.
Welcome, everyone. I need to introduce people who came here, right? So welcome, everyone, to the next ScalaWAW Meetup. So we have like two wonderful guests today. So Łukasz, who will be talking about GraalVM and going cloud native, and Kai, who will be talking about Distage and Zio. And I think both of those are not really presentations, but live calling sessions. So be prepared to have your brains like fired up. So Łukasz, the stage is yours.
Okay, thank you. Like Tomek said, my name is Łukasz. I work in VirtusLab in Krakow. I'm mostly concerned about cloud services, distributed systems, microservices. I did some work on reactive microservices for Tesco in VirtusLab. And now I'm pushing bytes through pipes and doing big data analytics in Tesco Analytics platform. So this isn't going to be a standard talk. It's going to be more like a random babbling mixed up with some hacking and trying to understand why things explode and fail. But the general direction in which I want to take you is called cloud native. So it's a kind of a new term on the scene. Most of you probably already know what cloud native means, and I guess most of you rather knows it by feeling what the authors might have thought about when defining it. But I went a bit and found out the original definition of cloud native. So what does it actually mean? And especially, what does it mean in our context, where JVM developers mostly working with Scala, I presume. So cloud native applications are meant to be executed in cloud setting. What is cloud setting? Cloud setting is dynamic infrastructure, immutable infrastructure that is set up programmatically. It's not really set up once and then it's not like servers. You just set them up and then have ops team watch them and treat them like eggs. You set up everything as code, execute it, do the same for all the changes. So you can version it, you get cloud infrastructure, and there's a lot of fuss related to how this all works. So my personal thing is that Java and Java ecosystem were developed with completely different setup in mind. So what was targeted was long-running servers, huge application servers that could handle multiple applications simultaneously that could be deployed as vars. And that's really not the setting we are currently in with cloud native. As you can see in the definition, we expect loosely coupled systems that are resilient, manageable, observable. So JVM resilient, okay, yes. Manageable, observable, yes. I would say that JVM is probably one of the best in this area. I would say that getting information about JVM, about the process that's happening is quite easy, and we have a lot of tooling that isn't really possible for many other languages. So Insight is great. But there are things that still aren't very good. I would say those things really, to some extent, outweigh the benefits. So what you can see in case of Kubernetes ecosystem is that there's a completely different language, Go language, which has taken this scene, I would say wholesale. They have already won the cloud battle. And the definition doesn't really mention how could that happen. The thing is, Go is fast, but that's not really the problem with JVM. JVM itself is fast too. Go is lightweight. Go is fast to build, Go is fast to deploy. It's lean. It takes small amount of resources when it works. That's arguable if you know how kubelets work, for instance, but let's go with that. Anyway, Go is lean, and JVM. Is JVM lean? Is JVM able to work with limited resources, able to work quickly, get shut down quickly, and deploy it again quickly? Is JVM really a good language, a good platform to handle dynamic scaling on demand? It really isn't, and the situation was, I would say, bad until last few years. But then new things happened, and what I want to show you during the live hacking / coding session would be how far we got up to this day. And I say that this session is hacky, and a lot of unexpected stuff is happening because I was following the cloud native trends in JVM setting for like 2 years now, and it's been like constant pulling the rug out of my legs with how development works, how people tend to change APIs, introduce breaking changes. This isn't a new talk. I have given it before, and some new occurrences happened on the way. Some new versions of software appeared. Other versions, other pieces of software became production ready. So I'm not really sure what's going to happen. Wish me the best luck, because I don't know if it's going to actually work the way I intended it to work. But I guess it's a journey to learn something too. Okay, let's start with something that we already know. Who here uses functional programming? Pure functional programming. HTTP4S. Okay, so there are hands. We are going to work on a application that is that's probably not the version I'm looking for. Bugger off. We're going to work on an API that has one sole purpose of storing information about my favorite whiskeys. So
excuse me,
yeah.
can you make this font bigger?
Font bigger. In the terminal, sure. Yeah. Better now? Here? Can you see anything? Okay, great. Now you're in the better position than me, because I don't really see anything here. Okay, check out. I'm going to skip the part in which I'm trying to prove that I know what I'm doing when working with functional programming, because it's boring. Well, let's get to the actual meat. I think this is the part in which application actually has stuff in it. Can you see anything here? Let's try and go for presentation mode. Okay, so that's the controller. You can see, you probably notice by now, doesn't do much stuff. Quite simple REST API for managing whiskeys. It also has a starting point and probably something else too, like the part of the application that handles talking with PostgreSQL database, because we have to persist the information about whiskey somewhere. Okay, so I'm going to quit this now for a bit. just to start SBT. Okay. That's fine. That's too far. Okay. Okay, so what I'm doing now, I'm trying to build a Docker image of our microservice running with Oracle hotspot on an Alpine-based Docker image. We have some Java opts that we need to use. Does anyone here not recognize this hotspot options? This piece here. They were included, I believe, quite time ago as defaults, but they were quite new when I was giving this talk for the first time. So there was a problem as the JVM wasn't really aware of the kernel feature called cgroups, which allow us to use containers. So what JVM did was just to ask the host system how much memory does it have, and if you didn't give it any flag controlling the ratio of the memory that it should take, it took 1/4 of the memory available on the system, which was quite unfortunate if you had 256 gig on a high-power server in the cloud. So later on, they have added this flag, which allows you to use cgroups, which are then passed as parameters to starting container for memory allocation, and then hotspot sees this and takes only the amount of memory that is available in the container. We also use this one just for letting the process running in the container know that it shouldn't take 1/4 of the memory available in the container. It should take all the memory because it's limited to this box. Okay, let's try and build it. Reload again. Does it even compile? Okay, as you can see here, entry point for Docker image was successfully passed. We can see the options that we wanted to pass to hotspot being properly passed. Let's try and run it. Okay, the interesting part here is we have also included this little thingy, which tells hotspot JVM to show memory settings for the VM, and that's what we see here. As you can see, it has correctly managed to see how much memory has been given to it by the parameter memory here. We have given only 192 megabytes, which I would say is quite a lot for an application that only connects to Postgres to insert like 4 columns of data, but okay, Java. And yeah, so things to look for here are Jetty gives us information about how long it took to actually start JVM and start the server listening. It takes almost 3 seconds to start the application. We also have 92 megs available of the heap. And let's see whether this works. I don't think it would, because of reasons. Yeah. wrong port. Yeah. Okay, let's see. Something just broken again. Okay. That should be quite easy to fix. I guess my Postgres instance isn't working as it should. Shut down the existing instance and start a new one on the correct, let's hope, network. Oh no, that's not the one. That's okay. Oh, come on. Okay, so what I'm trying to do now is to migrate file. Okay, I'll go back. That was cool. Okay, 4, 5, 6, 7 here. And in the build, we will switch options. Hotspot. Okay, this should work. Probably. Okay, so we got our first answer from the application. As you can see, it returned empty JSON. There are no whiskeys in the database. We should be able to put one of the most popular whiskeys in the database and check that the application actually works. We could also try and see what happens if we try putting some load on the application. We won't see much here, but what is interesting is to see in what conditions will our application still behave as we would like it to behave. So I think that with this amount of memory, which is not very much in cloud setting, but it's not very efficient if you ask me, giving also almost 200 megabytes of memory to a very small API is wasteful, I would say. The application is stable, JVM is working as expected. So let's try and go a little bit lower with this. Let's try 128 max. You can again see that the maximum heap size is lower. I think there are some smart tricks that have been included in Hotspot that allow it to compress the amount of memory that itself is being used for off-heap caches and off-heap pools of memory used internally. The actual method to calculate how much memory JVM itself is taking is hard bordering on impossible, and believe me, I have really tried to find a way to estimate how much memory will be necessary. It's a lot better since JVM is capable of reading C groups, but before it was painful, at least, to estimate how much memory do you actually need for JVM. So let's see whether this works. It's also worth noticing that if we lower the amount of memory given to the JVM, the startup takes a bit longer, and this will continue to happen. The less memory JVM has, the worse the result. 5 concurrent, 10. Okay, so we are still working with 128. Let's try give it a bit less. Okay, so this is one of the points that are surprising to me, because it seems that some work has been done, or we are just lucky. Let's just check this theory right now. Anyway, it seems that some work had to be done on Hotspot on the 8th Java version, because last time I was doing this, and that was on Scala days, it was crashing on 96 max for sure. It was just quitting. Oh, no, we're just lucky. Yeah. So that's how it starts to behave if we go below 100 megabytes. It might work, won't be stable. If you try and do this in Kubernetes, you will probably run into a situation in which your application starts to behave erratically. You get crash loops, and well, it won't look nice on the dashboard, to be sure. Probably will be painful to your users too. So 128 megabytes was the threshold on which Hotspot was behaving okay. It was fine. Let's see whether we can go a bit lower, and how far we can cut down the memory usage of JVM, and what can we do about the startup time, because as you can see, it varies, but it's going rather slower than faster. So I believe this is set up properly right now. We will try and use another branch of JVMs. So IBM was working on a JVM that was called J9. They have open sourced it some time ago. It's called OpenJ9 right now because, yeah, it's open, so had to change the name. And it seems that IBM was trying to take what they had, which was a custom JVM, and go with it in a bit different direction that Oracle has taken. But we'll get back to Oracle in a minute. Let's talk about what IBM did. So IBM started with noticing the fact that cloud deployments are probably going to be the thing that's going to happen most commonly with JVMs, and the epoch of running huge application servers is probably beyond. So what does it mean? They hired engineers to work on JVM startup time. They came up with a lot of improvements around this area with, for instance, a feature that allows you to cache your compiled classes. So when JVM runs, JIT compiles classes to native bytecode, and then when JVM is closed, this compile result is just thrown out. It's thrown to the garbage most of the time. So they have arrived at this idea that you should probably just store them for the next run, or maybe share them between different machines and different JVMs. Let's try and see whether this actually holds, and whether they actually arrived at any improvements in area of running stuff in small boxes linearly. Okay. Another reload, another Docker. Okay. Let's try and see. Okay, so let's start with 96 max. You can see that we have changed VM here. The fast time is, I would say that they didn't really deliver on this promise because startup isn't very much better than hotspot, but let's see whether it's stable. How many people here know what WRK tool is? Okay. So for people who don't know, sorry, that's a benchmarking tool that currently is trying to siege the application with 5 concurrent connections. Yeah, so no luck here, I would say. It seems that 96 max and 48 max of heap size is enough for OpenJ9 to run quite stably. So 5 concurrent connections for 10 seconds. Okay, so let's try and see what's the threshold for this JVM. How much? 64? Let's try 64. Less? More?
32.
30. We'll get there. Let's see.
At least starting time is consistent. Startup time is consistent.
Yeah, it didn't increase.
I increased, okay.
No, it didn't.
I did, yeah.
Let's see. There was
Even lower.
3.7 and 3.6. Yeah, no, I would say
Yeah, so
it's marginal. Probably more related to how kernel works itself and not the JVM. But yeah, it's stable. It's on this area. It's better than hotspot. Yeah, and it works. We can't kill it. So I heard 32. Okay, 16 megs of heap. That means that the rest of JVM is taking 16 megs also. I would say it's pretty compressed. Oh, well, no. Maybe we were just, unlucky. I've seen this happen before, and one curious thing was that I tried to actually connect to the JVM and see what was killing it, and why sometimes it did start correctly and why sometimes not. And this actually is bound to how garbage collection works. If we can force garbage collection fast enough, it will clean up mess before the rest of the process occurs, and then it will start up correctly, but sadly it won't really execute any queries because out of memories. Okay, so 32 megs is not enough to run this. Okay, so back to our dear companies working on getting stuff done for us. So the second big player in this space is Oracle. And Oracle has been doing something completely different. Oracle has been working on a project called GraalVM, about which you have already heard probably. What is GraalVM? So let's maybe start with a question. Who here used GraalVM? Okay, out for me earlier. Good for you. So GraalVM itself is another implementation of the internal compiler that is used inside of the JVM. So the JIT that was being used before Java 9 was C2. And why is it really important that GraalVM is a compiler replacement for JVM? Compiler is responsible for getting our actual code running after the warm-up phase. And if we can build a compiler that is independent of JVM infrastructure, which is what Oracle basically did, we can do a lot of completely different stuff with it. For instance, we can build a frontend for the compiler that will use some kind of parser that will be able to work with different languages, translate them to a single intermediate representation, and then output it to completely different backends. So since Java 9, we have now JVM CI, which is JVM compiler interface or compiler infrastructure, not sure, which is basically extension of JVM that allows to use different compiler backends for compilation of for JIT compilation during runtime. And that allows for GraalVM to be used, which is, by the way, I think default from Java 9. What happens now is that we have GraalVM as a separate JVM. It's a separate distribution provided by Oracle Labs, and we have Graal itself as a replacement JIT compiler for JVMs, which are included in OpenJDK and Oracle JDK, and also tooling, which is added to GraalVM package and available via the GU utility, which is a package manager for GraalVM itself. So enough of explaining, let's do something with it. We are going to completely skip the idea of using JVM with Graal as JIT compiler, because the only thing that actually is interesting about it is that it makes programs run faster, but that's the thing that they are probably advertising the most, run your programs faster with GraalVM. It actually uses a lot more resources than plain normal Java 8 JVM, so it's more expensive, and the startup is even slower. because of the fact that they had to use actual Java library as the compiler running alongside your process running in JVM, and only after I think a year of development they were able to do the most interesting stuff that has happened, in my opinion, recently in the whole JVM ecosystem. They were able to compile their compiler from a Java library to a native library that they have then included via JNI interface to the JVM. So they have written compiler in Java, compiled it to native library, included in the JDK. And I already mentioned tooling around GraalVM. The tooling here is especially native image tool, which allows us to take any actual compiled Java code or any basically JVM language that is compiled to class files and compile them down to a native application. Okay, let's see. Where are we with this? Fine. No. Yeah, that's wrong. Okay. Let's go even further into the future, because I'm not sure whether the fifth iteration will work. This is stuff that worked today in the morning. I hope it will work today in the evening. So, yeah, same dependencies. There's a bit different thing here. We are using a different from Docker image. We are going to use Alpine, which doesn't hold any JVM itself, so no JVM runtime. And we are going to actually copy file, which is here, the result of binary compilation. And as you can see, there's no Java command before it. It's just a plain binary executable. So, how much time do I have left?
As much as you need, probably.
That's great. Okay,
Show
let's
us
hack
everything
things.
that's interesting.
Let's hack things. Okay, so
10 minutes.
come on, getting nervous here. Okay.
You're doing great.
Thanks. Wait until it explodes.
And boom.
What I would like to show you is that I've been working on stuff, because I do those things. I've been working on a way to actually make setup of everything that you need to have your application running with native image a lot faster. It's been going slowly because of breaking changes and the fact that stuff is mostly in the works, but it will help us later on. But let's try and see what we can do with plain command line approach. That's why I have only built an assembly. So we have FATJAR. We'll try to build native image of it ourselves. So quick explanation. We are going to use verbose flag just to see what's happening, and because it makes debugging a lot easier. We are going to use the no fallback flag, which is meant to tell native image building process that we don't really want a fallback, which is in Oracle parlance, if stuff can't be compiled to binary, let's just run it with a plain JVM introduced to the package. So I've talked with Wojn Jovanovic, who is one of the original Odersky students from EPFL, and then switched to Oracle Labs and work on GraalVM. Talked with him about this. He told me that this is actually only included because Oracle lawyers came down to engineers and told them to include it, because has to be there because stuff cannot fail. So we have to include it, but it's meaningless. The original behavior of this application was no fallback was always on. Then it was added as an additional flag. If you don't use no fallback, you might get into a situation in which compilation breaks down and you don't get a native application. You get JVM packaged with your jar. That's the output. That's what lawyers want. So, blame lawyers. Okay, so this flag is quite important, and I think we will skip it just to see why it's important. So, probably we should start with this. Okay, so what it does the smart thing, uses JVM itself underneath. Yay. That was fast. I didn't really think it will fail that fast. Did they make it fail faster? Anyway, let's try and see what was the exception. What they did is they actually built a compile server. So it starts a compile server underneath and then just talks with it. And that's nice, and it would be nice if the compile server didn't get corrupted once in a while, and then you have to kill them all and start again. Okay. Main entry point class.
Does it need main class first?
Hmm?
Does it need main class first or before the jar?
Might
It
be.
looks like it.
You know, you might be wrong. I don't think it should, because this version of this command worked fine.
But
Oh,
it's the
I'm
jar
dumb.
flag.
No, sorry, I'm just plain dumb or just blind. I'm not sure. Yeah. We have to tell him that it's a jar and there's a manifest inside. Yeah, so it's doing a thing. Another interesting trivia is that person that was working in Oracle Labs and was implementing the parser, which takes the most of the time during this process, was writing it in a Scala style, and hence they had to rewrite it because performance wasn't really good. Things you can learn. Okay, so there are some warnings. Warnings are actually okay. I never really got down why this is happening, but that actually this piece means that Scala isn't really outputting correct class files. They are not according to the specification, and native image knows, but they are just letting us with a pat on our hands, and we can try and make it work. So. Is anyone interested in what's happening inside and what's happening in this exception? Because I can try and explain this stuff to the extent of my possibilities. But what native image does is, let's start with the previous failure. It was failing because it didn't know the starting class, this class that is the entry point to the application. I have added the jar flag, which has told the process that it should look for a manifest which will contain information about the main class. And that's the most crucial thing here, because what native image does is they open the main class, start looking for main method of the application, and start building a tree of all things that are available, that are being pointed to in terms of parsers and abstract syntax trees. So they build a whole tree of everything that is being used by application. That's quite important, and there are quite important results and possibilities due to this. They built a tree that contains all classes and methods that are being accessed by the application. Now, problem with JVM-based languages is that JVM itself is running with an open world assumption. You can build your application as a fat jar, but nothing really prohibits you from adding additional classes on runtime. Nothing really prohibits you from creating classes in the runtime. What native image tries to do is to build a native application, which doesn't have such capabilities. They can't just add classes in runtime. They can't do anything like that because it's just a static code. So what they have to do is they have to completely turn JVM world upside down and start thinking in assumption that the world is closed. That this is the world as it is, nothing will happen, nothing will change later on. And everything would be fine and dandy if not one thing, which is how much of the JVM is dependent on reflection feature. So the dynamic code features are quite prevalent in JVM, and you don't really have to look very far to find reflection in the code that you might think is completely static. For instance, Java 8 lambdas are implemented using method handlers, which are a form of reflection and code generation in runtime. So native image is capable of doing some reflection analysis on its own. It cannot do anything about stuff that it's not actively being told about. So they went quite far. For instance, class for name call can be parsed by analyzer, and the class can be then located. If it's found on the class path, it will be included. But there are multiple situations in which you can't really do that because, for instance, like when you load JDBC drivers, most of the time your framework uses a variable passed to the class for name, and it's a dynamic variable. You can't know what's there. So that's the place in which a native image gets lost most of the time. There are ways to handle that, and I will show you what we can do about that. In this particular error, oh yeah, so that's what I was hoping on. They have changed the error, which is bad for me, but not that bad for you, because I'm trying to wrap their errors in a tool that will help you work with this without knowing all the errors that they have included. The problem here is that if you are doing compilation in closed word assumption, you have to somehow deal with the fact that JVM classes can be initialized, and they are initialized by class loaders when they are first loaded. So it's a bit tricky thing, actually, because what native image does is that they assume that if you don't tell them explicitly, mostly due to how Java applications work, and most of them have reflection used in this case, if you don't tell them to initialize the class during the building of the native image, they will try and defer initialization to runtime of the native image, which sadly doesn't really work well for Scala. And I would say most of JVM code, they have told me that it actually works better for their bigger customers like Spring. So take whatever you want from that. Anyway, we can add a missing flag here, which was forgot how it was called. Yeah, initialize it. So this flag tells native image to try and initialize all the classes that it will find in the points2 analysis during the build time of the native image. It has several downsides, like for instance, there are cases in your applications when you want, for instance, to start a special thread and allocate it to a static variable, like create a thread pool, for instance, as a static variable. And this is problematic for native image because it can't do this, because they only initialize your classes in the native image build time, only to see what is the end result, and then they just scrape the end result from memory and put it verbatim into the native image. So if you start a thread as a static variable, that means that there's a dynamic thing running during the native image build time, and you can't do this. It will blow up. So we'll now tell native image to initialize everything at build time. And what I have found is that it's actually easier to whitelist classes that have to be initialized in runtime. And most of the time, those classes will actually run. They will work fine being initialized in runtime. Oh no, it failed.
Why do you need to initialize these Scala classes at build time?
That's a very good question. Oh, I think that's an error that I have seen today. But that was with static. We should probably start with killing server. Try again. I think that there are parts of Scala standard library that work fine if you initialize them during native image compile time, when you are actually boiling things down, but they don't really work nice. You know, the points to analysis changes when you have to assume that the class on the other hand of your arc, you know, you're in the starting point and you point towards something, but you don't know whether that thing is initialized already or not. And relationships between them are different. That's from my understanding of error messages that I get while working on it. I don't really get deep inside of the code. Oh yeah, yeah. So yeah, that was the server itself that got corrupted and crashed the compilation. Most of the time I'm just setting the flag no server and be done with it, because for all the time that you gain by compilation process being faster because it runs in a hot JVM, you then have to wonder why it's broken. And in our CI environment, I'm using no server only. It's just not worth getting down to logs and debugging why they break. Yeah, so we have now a static native image of our application. It's marked as executable. That's a nice touch. Let's drop this and try and see whether this works actually. Okay, so first thing that is worth noticing here is 7 milliseconds startup time for an application that is REST API. Cool, right? Let's see whether this works. I hope it works. No, it doesn't, which is not nice. There's no PostgreSQL driver on the class path. There's no class path, but yeah. So, what's the problem here? I can show you the code that actually causes this problem, and we can weep together in sorrow that we can't do anything about this because that's just how we write our programs. That was F1. So the offending piece of code is here, and that's, some of you probably know this code, that's doobie we're creating the transactor from driver manager. And here's the class name. As you can see, put as a nice, completely obfuscated from a static search string. So class for name gets a dynamic variable, and well, it just resigns. It doesn't include the class that we would expect that would be there. So what can we do to make this actually work?
If we implicitly call class for name with this string, will it work?
Yeah. That's one of the funniest things that you can do. You can hack stuff with this. Let's disregard that ADI is not liking our not imported project. We are starting from here, and for people that know the HTTP4S stack good enough to notice that I'm using StreamUp instead of IO app, yes, I'm using quite antique version of HTTP4S, and I will explain why later. So we could possibly do class for name. Here, and you know what, we should probably make it bound to something. It's a unit, isn't it? No, it's a class. I'm not. Anyway, we should bind it to something just for not shit and giggles, but just to let know the process that it shouldn't just throw it away. And native image is quite aggressive when talking about ditching stuff they think won't be used. So a lot of stuff is used later, but they have treated it as trash and throw it. Okay, so we have to do assembly one more time again, and now we're doing this in here. Yeah. Okay, so we have a bunch of new errors. So as you can see, yeah, there's, like I said, it's a tree. So when you start, you have to finish somewhere. When we have loaded the org PostgreSQL driver class, it has included its own subtree of classes that it was pointing to. Now the problem here is that PostgreSQL driver has bindings for very different and multiple different things that we probably won't ever use, like, for instance, in this case, platform Win22 classes. But native image cannot know which one will be actually used. So what they can do is only complain if class path doesn't really boil down to anything sensible. So we are going to go around this problem. So Oracle Labs team, the GraalVM team, being great engineers that they are, came up with a way to actually see which classes are being used by your application in runtime in actual JVM. So you can run your application in a JVM, and when you do that, you can include an agent that will track all the calls being executed from your main method down to the last bits of the code that is being executed. And they can color the tree. They can color the leaves that are, the branches and leaves that are actually being used. And then they can throw everything else out and generate something that is called reflection I have an example of this reflection config. Sorry. Can I get a glass of water? Thank you. So it's a JSON file that looks something like this. It's quite simple, as you can see. Just mentions which parts of the class you want to import. You get all declared constructors, public constructors, like methods, public methods. This one here is for Jetty, and thank you. And interesting part here is that during the evolution of GraalVM, there was a point in which this little file, this reflection configuration, was enough to get this application run. But things at internals are changing so fast that there are many breaking points between versions, and you can't be really sure what will work in this or this version. So I'm on Arch. It's painful because every, I think, 3 weeks or 4 weeks, I get new versions or patches. And that's why this presentation isn't really stable, because I'm always on the edge and things are broken. But the thing is, thanks to the agent, we can do a clever trick. The clever trick isn't very complex. It's just a small piece of code that includes the agent while running our tests. So I have tests here for this application. And I would say that the most important test is to actually run the whole thing. So we don't want to just do unit testing, because unit tests won't load all the code that is actually needed. So what you want to do is to build a whole, that will be end-to-end test, not an integration test, but a whole end-to-end test that will actually run your application and evaluate all the code there is to evaluate, all the branches of your code that you want to evaluate. Quite hard, to be honest, but if you are trying to do that for small applications, doable, and we can then measure up whether the gains are worth the effort. Okay, so yeah, so we have integration tests, and if we are on the correct branch, it should be possible to do create native image configuration. So what this task does is it runs our integration test with an actual container of Postgres underneath, so it talks with the database. So we are using this org PostgreSQL driver class. It actually started the whole application, as you can see, and everything worked. So now we are going to build a native image of it using the same procedure. We are going to generate a lot of configuration, which is being stored here as meta-init native image. And well, there's a lot of stuff that agent was able to find. Interesting thing here, which is more like a hack internal thing, is that some miscon save class is being used somewhere underneath all this code, and we have to let native image know precisely that unsafe is going to be used, so that they can provide their own version of unsafe, which is part of SVM, which is substrate VM, which is the you could say run. It's the part of application that starts your main. Okay. Oh, yay. Points too, yeah. Oh, yeah. I made the error of trusting the daemon again. Dealing with demons is a bad idea. So let's slay them all. Fingers crossed.
those settings, or I misunderstood?
Yeah, what I'm doing is I'm running our integration test with agent added to the JVM class path. It's quite trivial, to be honest. What I'm doing here is,
And
yeah,
the
here
test-
you can see that I am modifying this setting called job options in test, and I'm also letting SBT know that it should fork a new JVM in testing. So that means that it will actually start a separate JVM with this command line option added, and this command line option is just it includes native image agent with configuration, where to put the generated configuration. That's all it actually does. Thing is,
include also test dependencies in the native
no,
image?
the thing is, it would actually, and that would be quite bad because we have like Docker Java, for instance, in test. What I'm doing later on, what I'm trying to publish as an SBT plugin, but I still can't stabilize API because of how often things break with GraalVM, is to, it's in project. What I'm doing is I'm creating a class loader for compile scope, and I'm loading all the classes that are in the compile. So the classes that will be included in the actual factor will land in this class loader. It has its own downsides, like probably we don't need all the classes that are in the fat jar, but it allows us to do cross filtering out the classes that are on the test class path. So when we load those classes to the class loader, we can later just check whether the class that comes from the test class path exists in the compile class path. If it does, we want it included. If it doesn't, we just drop it from the configuration. And actual agent, yes, it does generate configuration for classes from test class path. So you get information about all the reflection being used in your tests, for instance. Okay. This thing is persistent, and I don't know why it's actually happening, because we have built it. Or maybe not. Let's try and see whether we can add this back. Let's try and start with a clean slate. Yeah, I did reload.
Takes a while.
It didn't fail yet, which makes me optimistic.
There you go.
Okay, so 61 seconds. That's because we have turned off the server. So that's the price you have to pay for it not to blow up, sadly. But we can hope for improvements. Anyway, we have a native image here, which is nice. Should be able to use it. Yay! Okay, that's nice. So not only it has started in 2 milliseconds, it has also fetched our results from Postgres database. So it's a working actual REST API. And what we want to do now is to make a Docker image of it. I'm quite afraid that if I do this, you know what? Yeah, I think SBT is, dumb this way. It doesn't really track caching. It doesn't really track what's been built before properly, and that means that we will have to recompute everything again. If we try doing Docker, let's see. Oh no. Alt, everything. Okay, so sadly we'll have to build everything one more time. The point is here. Could you speak a bit louder?
How big are the executables?
It should exist here. Yeah. 30 max. I would say acceptable in Docker Ranch. There's a static flag which allows you to generate a bigger file, but it's a static native application, which means that it has its own bindings to kernel. It doesn't depend on having libc or musl in LD path. So that's nice. You get, I think the image is around 45 or 50 megs then, but you can use from scratch with Docker, which is quite nice because that means that you have like zero overhead from the file system itself. Like I don't mean performance overhead, I mean size overhead. Okay.
How memory is managed in the native application?
A bit louder.
How memory is managed in the native application?
Oh, well, that's a hard one. I'm not an expert, but they are not using Java memory model at all. There is no need for object padding, for instance, and things like that. They just use their own memory management. It's garbage collected, so it's more in line with Golang, you could say. The garbage collector that is included in native image, I think, is either Tablet. Okay, I think we are happy with the end result. Let's hope. Okay, so we were at 32 max. Oh, nice. That's hard. No such fun. That's unfortunate.
Use A before containing it. You want to go to the back.
Minus IT?
Minus E.
Oh, T.
No.
2 points.
It should work with IT. We are using Alpine, which means that there should be S, H in it. Bobby, flag ordering.
If there's an entry point defined, you need to provide it as an you need to put SH as
command line.
as a command line argument to entry point.
Oh.
Minus entry point SH.
Okay.
You need to move this in SH.
Mhm. Thank you.
Yes,
But
but
it's
before the
Before the
Hmm.
IT is missing it.
Yeah.
Ah.
After. Okay. Wait, what? Does anyone have any idea what's happening? Okay.
It looks like
Can you
it
show the
was
size
like
of the file?
It's
compiled.
link. No, please not.
Okay, so there's an actual file here, and
It's a recursive application. It's a recursive application.
Try absolute path.
no, we didn't do the stupid thing, and we did include information to no fallback stuff, so no. And it would shout about missing Java, so no. I'm not really sure what's happening. Anyway, we're out of time, sadly. I hope that I was able to provide with some information and entertainment maybe. And we can see, beside that, the nice starting point. What I wanted to show you now was that we need this flag because there's a garbage collector inside. And as you go down with Docker memory size, you can go down, I believe, to 19 or 16 megabytes. That depends on the version of GraalVM that did the compilation of native image. And you can have a stable running application using Scala, purely functional Scala, in 16 megs of memory, running in a container, which is from scratch, which is, you know, just 45, 50 megabytes of pure binary code. It works fine, and it's faster than OpenJ9 running in 48 or 64 megabytes, I'm not sure. But it was a bit faster than actual JVM with twice or 4 times more memory. So there's a lot to actually gain from this. We can see that it works without any problems.
Can you debug this thing? I don't know, using normal Java tools like VirtusLab and stuff.
And that's when you hit the paywall actually, because for a long time it was completely impossible to debug this. And I think stuff gets pretty mangled inside, and GDB wouldn't really help you. I think you have to have ABIs to get GDB working and symbols, and they didn't probably really get down to building that. But the thing is, if you pay for enterprise version to use this introduction, you can actually connect a special version that is included with GraalVM of the Visual VM. So that's nice. You can connect a visual VM, a special version, but nevertheless visual VM, to a running native application that was built from Java code and it works. So sorry for no Docker presentation of native application, but it is what it is. The last thing about the flag that I'm adding here, if you don't do this, if you don't tell the garbage collector inside of the native image to start running once it allocates 16 megabytes, what it does something which is, in my opinion, it is probably safe if you have a lot of memory, because you won't hit the threshold when kernel just tells you to bugger up and kills you. You get to the point when ratios of used memory equalize and garbage collector kicks in automatically. But if you don't do that and you build a small application that you want to run in a very constrained memory environment, like 32 megabytes on a Kubernetes cluster, which is quite reasonable if you try and build small API in Go language, for instance, it will probably run for like a few minutes. It will answer your calls, and then after a few calls, allocator will cross the threshold of OM killer, and before garbage collector can actually start working, your application will get killed. But if you pass this flag, XMN 16 megabytes, that means that garbage collector will start working once the first 16 megabytes of memory is allocated, and in the end, your application will run stable in this small constrained environment. Any additional fast questions with accent on fast question?
I think we can get questions down to this outside
sure.
the pizza.
The second presentation, please welcome Kai. And live code. Let's go.
Okay, so okay. Yeah, let's start with a few words about me. So I'm an employee at a consultancy called Septimal Mind. At Septimal Mind, me and Paul Shushev, the CEO, have developed a framework for our internal needs and enterprise needs, an open source framework called Izumi. Izumi consists of 3 parts: Distage, state dependency injection framework, log stage, a structural logging library, and IDL Ingra and RPC and interface description language. So in this talk, I'm gonna go over one part of the new framework, Distage, and yes, I'll use Zio, but we will not be using Zio directly. Rather, we'll be programming in type spinal style against Python protect classes that describe some capabilities of a model that is kind of like Zio, that supports some of the capabilities that Zio has. So that is the relative. Now, the premise of our task. Let's suppose that we work for a company that develops video games, and we were tasked to develop a system for managing user profiles, player profiles, gaming nerds or whatever. In a game, we probably want some kind of scoring, and we want that score to be displayed. On the user profile. We have some piece of data that the user submits about themselves, their name, or their about me section, and we want to display their rank and their score. Whenever someone views the user profile, we want their score to be visible. We also want a separate leaderboard for those scores, so that ranked from people with a high score to people with a low score. So that is for our data model. Let's think of service interface that allows to accompany the standards. I will be using bifunctor effects here. So create interfaces that look like that was fine, but they will actually feature 2 parameters, not 1. And the first parameter is going to be here. So we'll have our first method, which is submit score. If one our user be able to submit those scores to the ladder, and we'll be able to get the actual error, just every user score sorted in order. So an example is fine if we just return a list of everything. Since we're programming against a real database, anything that happens here, so we define query failure. Define query helper as a helper exception that we just print. Cause the actual exception that could happen. For example, in SQL, we could just the database could be deleted under us, or we could have a network failure. So anything could happen here. We can't use nothing as an error. And for our other interfaces, we'll need a profile management system so that the user can actually submit their profile. This will be a query failure that will return us nothing, and this will obviously return the user profile, but only if it actually exists. So yeah. And we'll need a third service that will actually put these 2 pieces of data together. It will create a ranked profile from just user data and their position in the leaderboard. But only if they actually submitted a user profile. So that's it for our interfaces. This is, since we've defined every interface, is actually enough for us to create some tests. It's an idea failure. Yeah. This is actually enough for us to create tests for the ladder at least. So I'm just going to paste the entire test suite for the ladder. I'm going to paste the entire test for the ladder. We'll start with pretty simple invariant. We create some kind of random score, random user, set the score, get the leaderboard, and we check that the score is there and it's the same as the one we submitted. And a bit of a harder test is we create 2 random users. They both submit scores. We check the leaderboard, and we check that whichever user has more score must have a lower rank. And if they have the equal score, we just don't test that because it's implementation dependent which one will end up first, and it doesn't really matter. So this test only requires a ladder, so let's start by implementing a ladder. We'll start by implementing an in-memory ladder. since we're going to program in a purely functional style, we're not going to use a var or a mutable collection. We'll use a ref, a mutable cell, Scott's effect ref, to hold the state of the ladder itself. This will be a map of users to their scores. And this should be enough to implement everything we need. And implementations of these are also straightforward. We'll just take the map and add a new element. It should override wherever there was in the right map. And to get the sorted list of users, we're actually going to get the map and sort it. Now comes the tagless final part, because once we get something from the ref, it's still in effect. So to modify the inside of that f, we'll need a map function that a functor will provide us. So we're going to be using the bio hierarchy of bifunctor type classes, which will mostly mirror Scott's effect. So you've got functor, applicative, bifunctor, guarantee, monad and bracket, and bio is our bootleg analog of sync. It will allow you to import side effects. So this is almost the most powerful class in the hierarchy, which we'll try to avoid as much as possible, because we'll try to program to avoid to give as little power to our models as possible. Import syntax, and got the map. It's the list. We'll sort it by score, and we'll reverse the ordering because we want the highest score to be first. The default ordering is ascending. Okay. Okay, now let's look back at the tests. You can see that we demand, in each test, we demand a set of components that we want for the test. So we demand a ladder here, but the problem is that the ladder is just an interface. We can't conjure a ladder out of nothing. And if we don't specify how to construct the ladder, we will not be able to construct it. This config parameter specifies where Distage will look, in which package Distage will scan for modules that that describe how to create components. So let's add one module here. So plugins are modules that will be picked up by the class path scan. Usual modules will not be picked up by the scan. So this is ladder from ladder, and I'll just set this to IO. Let's set this to IO. And that's it. They should just call the constructor of the ladder to create it. Let's try to run our tests. We'll get an error. Oh, I guess it's not visible much, but basically it says that the instance is not available in the object graph. That was actually different. Yeah, we need a description of 0 runtime so that we can side, we can actually run zeros for our tests. And this just comes by default. That's just the model that comes by default these days. So you can instantiate it, and you have everything to run 0. Let's run again. Get another error. What does it say here is instance is not available in the object ref. It's got effect concurrent ref of 0 of map, and it's required by a ladder and fiber failed because of that. Now our mistake is to assume that a ref will appear out of nowhere if we haven't created it. Well, that won't happen, but to create a ref, we need to execute a purely functional effect. We can't just make it here as the default parameter because ref constructor has a type of f ref f, so it is itself wrapped in an f. Distage allows you to execute effects during as constructors for your components, so this is solvable. This time we'll need the most powerful class in our hierarchy because we're just going to perform some side effects. We're going to create a resource without a finalizer, and we'll stuff our ref creation as the acquire function. Let's use user ID score map and done ladder info, and this is I believe this should be sufficient. Actually, we will have to use trouble here. So this will be sufficient, and come back here and use from resource. This will now execute the effect as part of constructing the graph. Yes, our tests now passed. We have first passing test. Let's implement more of these services. I'm just going to paste them because, for example, because profiles is going to be pretty boring. We're going to create another ref. This time we won't create a new class for the profiles object. We just return it directly from the effect. And we can create an implementation of rank. Which will be the final implementation because ranks does not have an associated storage with it. It will just combine the results of ladder and profiles together. Separate. Scala FMT, please. Yeah. So given a user, first we'll need to retrieve their profile. User ID, and then all the scores. And all the scores. we'll use another for comprehension, but this time the mode will be maybe because we got an option from the first get profile. It could have been not there. We're gonna filter for that. Yeah, exactly. Filter for that. We should find the score in the ladder. Scores index. So we want an index of our user in the list. Good. +1, I guess, because we don't want to have rank 0. And the score will be the score of our user in the list. Scores find rank scores. Yeah. So this will be enough to create a profile. Implementation of ranks. Let's wire it all up and check if our new tests pass. So we still have tests only for the ladders, so we're just gonna need more tests. Just gonna need more tests. It's about time. We want to share our configuration across all our tests, so we'll move it into iterate. Yeah. And now I believe we're good. We can run all the tests we have. The tests for profile are trivial, and the test for ranks also not so hard. Just check that we assign a higher rank again, but this time in the profile. Okay. Okay, so we've implemented everything within memory repositories, but that won't be enough. It won't be enough for real application. We also want to have SQL repositories. So yeah, we want to search the query name with every query so that we get more debugging info. We're just going to wrap a DB transactor here. So yeah, we'll take the DB transactor, execute it, and make its exception a query failure instead of a throwable. Also get a side effect that the user of the transactor no longer has to supply their own bracket or their own bio errors. So in a sense, we've created a new effect of SQL that's going to abstract away anything that happens inside of an SQL. and will allow all of its users to have to require lesser type class instance. So I'm also going to paste the implementation for ladder in Postgres, because it's also not exactly interesting, but the interesting part that we will use a resource again to create the table when we want to construct a Postgres or Postgres ladder, and then we're just gonna then the ladder will be just a bunch of queries. Here we select, and here we insert, upsert, score. Same goes for profiles. Which is even less interesting. Because it's just getting set. Okay, so I'll need to wire all this together. We'll move all of these to a new module. That the module itself is also tagless. We do not really reveal the effect type. Instead, we use type classes to get the type info. We'll include it into the actual plugin. And we'll add wiring to run Postgres. Yeah, so we've got the Postgres repositories, the SQL algebra, transactor, and I actually forgot a bit of infrastructure to to actually create the transactor here. So we'll just let IDS sort out our imports. Here's the carry transactor. Here is cost effect resource. So this will just take the config and create new carry transactor with all of that. Postgres config is defined here, and this annotation will make Distage read it from a config file that we defined here already. So this will point to our local Postgres instance. I'm explaining it a bit more if we have the time. So let's get back and fix our wiring. And at this point, our test should use Postgres now. Actually, what happened? Ah, yes, we forgot also wiring for CATS effect, because the transactor requires some of the types of CATS effect type classes. We'll also need to add them. Replace our old zero plugin with one that adds all the implicits from zero interrupt cuts. Adds blocker and log as well. Yeah. At this point, this At this point, we're using Postgres. We can tell that by the log messages from Hikari pool starting, stopping, and creating tables. Now you may have noticed these little tags here. They will mark the module as containing components along. Can be toggled between one variant or another. So here we have a variant definition for a repository, which can be either a production or an in-memory repository. Our production repositories will reside here, our demo repositories will reside here. We actually include both of them at once, and that is so that we can switch them if we want to. Now we'll switch everything to the in-memory repositories, and we should also notice that it happened because the test is a lot quicker and there is nothing happening during initialization because there is no SQL required. What this allows us to do is actually create multiple sets of tests, or rather run the same test in different environments to check that that our code makes sense. Yeah. So I'm going to make a marker trait so that I can make these test dummies. I'm going to leave production here by default. Let's unfinal all of our tests so that we can create copies that run with the memory repositories. Done test, and we'll keep this first test. Now we have tests that run both in memory and production repositories at the same time in the same run. We can verify that we're running both by killing Postgres in our Docker and running the tests. You can see that half of the tests went out, and those tests that didn't have their dependency satisfied were ignored. So why were they ignored? Because we added integration check here that checks first for the existence of Postgres before allowing this to actually be created. If we remove this dependency, now the test won't be skipped. Will just
how this check is run?
What?
How is this check is run? It's not connected with this carry transactor.
Yes. So this is not an effect. This is not an effect. So what happens here is that for tests and for applications, Distage will first collect all subtypes of integration check first and create them first, and then trigger the resource available method which is not going to use an effect. It's going to be because it must be fast and synchronous. It's not very pure, but it's fine, I think, here. So this is implemented as an extension of Distage itself. But yeah, I guess I can go over more of that deal later. But basically, all integration checks aren't wired, they're first discovered and executed, and then everything else happens if they passed. So that means your application shouldn't get an inconsistent state where you first modified once, or you first connected to one data source, then to another, did some modifications, and then the second didn't actually respond, and you get an inconsistent state. You first check that everything happens, and only then execute anything. So that's good. Yeah. So we went over that, and this is actually. I'm just going to open my snippets. So, yeah, memorization. If we run these tests again, let me revitalize Postgres and run again. Okay, so if we look at the logs, we can see we're just going to count create and ladder table 1, 2, 3, 4, 5. There are 5 matches there. It means 5 times that 5 times that this query has run once for each test that we have, for each production test that we have, which is quite a lot. Setting up can be very expensive sometimes, so we may want to ensure that for all test classes, for all of our tests, we execute some kind of action only once. And we can do that by adding this configuration to our tests. So I want to create only, actually, yeah, hickory pool is even worse. Yeah, I want to create only one hickory pool ever. And we'll create one ladder repository ever and profiles repository. And let's run our test and see what happens now. So I'm going to check it, hickory pool. Get pool. 1, 1. So one pool started, one pool stopped. Again, each table created once. That's across test classes, completely global. Well, for everything that shares this test configuration, actually. If you use a new configuration, this will not be. This will create a new environment that is not going to share memorized components because a new environment could have any number of differences, and we don't want to share components between them. Yeah. So this. So I think I went over some of the testing features, and I've mentioned that we'll be using HTTP4S here, so we're going to create an HTTP API for our users to actually query and get all these scores, profiles, and whatever they really want. It's going to be an HTTP routes of throwable, and actually there are no parameters. I'm going to paste this also because I can't say it's very important, but it's also not Also wouldn't be very educational for me to type all that in. We request an HTTP for SDSL for our modem specifically, not for cat sale or for anything else we want. Yeah. We're gonna give user a letter, or give user their profile as JSON. What happened here? So, yeah, if someone doesn't know about this feature, this is very useful. You can mark import as always used, so it will not be removed even if IDEA can't figure out that it's used. This is a dupi type error. And we do not actually have any codecs for our case classes, which is a shame. We can add these. This will not compile. This will not compile, and we'll need yet another piece to launch our application. So, yeah, piece to act as our main function. Yeah, so what this does, we get a Blaze server builder, we add our HTTP API to that, set it to localhost, and create a resource from that. And then we convert the cast effect resource into a DA resource, which is a bit more general. Yeah, so Distage operates, instead of having one main function, Distage operates in units known as roles. A role basically defines an entry point, one of the entry points that you can have in your application. It can be a service that is long-living and will just start in parallel with other services, or it can be a task, so for scripting or other tasks. You may just add scripts in your executables directly, and this will tell that we want this role to be called live code. Yeah. Now we'll have to create a main outside of this, outside of our object, because otherwise IDEA wouldn't find it. So this configuration will repeat the same as our test. We designate the plugins subpackage as where we're going to search for plugins, nowhere else, and we're going to say that this role, live code role, that it must always be started. We need to add some wiring to make it all start, but so yeah, normal runs from here because we don't need them. Just move them here. Yeah, we need to add the role itself. this should be enough to start our application. Yes, now it's starting. We got an HTTPS application up and running, and we're going to use some curl commands to test that it actually works. I'll add a score of 100. I'll add my gaming profile. And then I'll check that I actually do get my profile back. The font here is very small, but yeah, I got rank 5 only. Yeah, and we got a bunch of scores already in our ladder because we didn't clean the database between our tests. So yeah, so that's it for the application itself. There's only one little problem remaining, is that these tests actually have some boilerplate in them that could be removed, and that doesn't really add anything to us reading the test. We don't actually have to specify every component. If you're familiar with, if you heard of reader monad, or especially if you heard of zero environment, you may figure out what I want to show you. So, okay. So we're gonna splice a bunch of boilerplate here, but what these types are doing is they're implementations of all of our algebras for zero's reader monad. Each usage of any usage of a method from such an algebra is going to expand zero environment with more of these little cakes. And Distage can assemble, and once we have a big intersection type, Distage will actually be able to assemble these cakes automatically. So I'm going to remove every single summon in every test, and you see now that these point to the reader monad implementations. And the type that actually makes it happen. And we can check that all of this actually works. So now we don't really have anything strange in our tests anymore. They're very down to the business right now. So yeah. So I think this example is not complete. And do you have any questions now?
How these things are wired about environment, and how you avoid this boilerplate with the managing the zero reader monad. So if you back, for example, in the test you have different, you need here this reader scores,
And originally, if you compose the reader part, for example, you want the reader, you want the scoring, you need to create some boilerplate. The copy from the Uber object into the specific one.
Yeah.
So
okay, so
there is magic to do that in the framework?
yeah, actually it's yeah. So let me explain. So once we have multiple uses of component in Zio, the Zio environment will expand to contain an intersection type of both of these components. Now what we have here is a conversion from a Zio into a provider. A provider is a function that can summon any number of any kind of arguments from Distage, and it will produce an I/O. So, and the test expects you to write these provider magnets actually in form of functions. But once we have a Zio, it's not a function, so it will trigger an post conversion here, and the environment parameter will request a trait constructor for the environment parameter, which is a macro that will basically generate for this type the following code. So why would it do that? Let's look at these interfaces. So there is an abstract method that wants to ladder I/O. Trait constructor looks at a trait and looks at all the abstract methods, and so it's a bit like in Spring you would initialize some variables with nulls, and make the framework do setting for them. Except here you don't actually need any classes. It just works on abstract traits in compile time. So for each encountered field undefined def, it will add a parameter to the function, and the function will be converted into a Distage function that will actually summon all of that.
And do you use macros for that? Or?
So provider magnet is actually it uses a macro, but it uses a macro for different reasons. It just uses a macro for reading annotations, because in Distage you can disambiguate, so we can have named components. And this will only be summoned by corresponding ID annotation. So we use macro to read the annotations, but it's actually just of converting a function of any arguments into a function that sums from the environment doesn't need that.
Yeah, I asked you about that because you removed the most important boilerplate that Zio introduced with this error part.
Yes, except yes,
And
yes,
this
yeah.
For me, it's huge benefit because I avoid to use arrow because I need every time write a lot of boilerplate. But
Yeah, but the,
your
yeah.
solution,
Yeah.
I have possibility to avoid that.
Yeah, you do. And well, the trade-off here is that you would have to make the same macro or copy that macro and make it white box so that the function actually has a known type, because here the function, the type is saved and hidden away completely in provider magnet, which is an applicable controls. Yeah. Any other questions? Okay, then I think we can wrap up.
We're done?
Yeah, I guess we're done.